Hey guys, this video is for newer people or people that just want to learn a little bit more about the controller types. I'm going to go over the different controller types and how you might use them in your show. I'll demonstrate some examples of how to design your own show and go over the pros and cons of the different controller types. This video is going to be kind of long, probably about 45 minutes, but there's a lot to go over and a lot of detail. So there's links below and chapters to skip around if you want. So let's get started. So there are three basic types of controllers. There's a local port controller, differential port controller, and a hybrid controller. And a hybrid controller is basically a controller that has both local and differential ports. So when deciding on what type or model of controller that you're going to use, there's some things that you need to consider. Consider the number of ports the controller has. Controllers can have anywhere from 2 to 128 ports. And more isn't necessarily better. The number of pixels per port. Some controllers will support 340 pixels per port all the way up to around 1600 pixels per port. Need to decide if you want to do port packing. If you want to do port packing, that means that you're going to put as many pixels on one port as you can. The only drawback with that is in a rare pixel failure, any pixels beyond that pixel are going to be out as well. So depending on how important it is to have everything going every minute and how quickly to repair, that might be an issue. But like I said, it's a fairly rare failure. You need to decide whether you want to do power injection or not, because power injection, if you pixel pack, you're going to need power injection. And the type of controller. There's got FPP-based controllers and E131 DDP-based controllers. The controller part itself isn't really much different, and they can both work together, and you can mix and match. They don't have to all be the same. So here's a couple of the local port type controllers. Now this is not an all-exhaustive list. This is just some of the more popular ones, and this isn't an endorsement for any of them or saying that some that aren't demonstrated here aren't good controllers either. These are just some examples. Got the Genius Pixel 16, that's an E131 DDP based controller. Got the Microside M8 Pi, which is an FPP based controller based on the DPI Pixel protocol. Got the F16V3 controller, which is an E131 DDP based controller. And you have the Culp Lights K4, which is an FPP based controller. So here's a local port example. You've got the main box with the power supply, and then you have it connected to the pixels. Some local port controllers do have the capability to add expansion boards so that you could then send data to differential receivers known as remotes. So now we'll go over what a differential control, some examples of some differential controllers. Again, this isn't an all-exhaustive list. You got the Genius Long Range Controller 40 port, which is E131 DDP based. You got the K40, which is FPP based with 40 ports. F48V3, which is an E131 DDP based controller. And a K128, the monster of them all, which is FPP 128 ports. Now this is 128 logical ports, not physical ports, and we'll get into that a little bit later. You cannot connect pixels directly to any of these controllers. You need a differential receiver to connect the pixels. Now these receivers are commonly referred to as remotes, and the remotes can also be classified as a normal or smart remote. The normal remotes are sometimes called dumb remotes. If you're using a smart remote but not chaining to another remote, then it's suggested that you configure it in normal mode. Each remote will have 4 ports to connect pixels. There are some newer remotes coming out on the market that's going to act like 2 chained smart remotes, but we're not going to get into that in this video. For normal or dumb remotes, you'll run 1 network cable from the controller for each remote. So if you have 2 remotes in a box, you're going to need 2 cables from the controller to that box. The smart receivers allow you to connect the receivers in a chain, so you don't need to connect multiple network cables from the controller to the remote. but you're not adding any logical ports, just physical ports. Let me try and explain. It's a little confusing, but there is some important terminology. A controller has logical ports. For example, an F48 has 48 logical ports, the K40 has 40 logical ports, and so on. But the receivers have physical ports. Each receiver typically has 4 physical ports. And this concept can be a little difficult to understand sometimes. So the controller has several RJ45 jacks, each one numbered with a range of 4 logical ports. In this example, you've got 1 to 5, 6 to 8, 9 to 12, etc. These logical ports are where the limitation is defined. So you've got ports 1 to 4. Each one of those 4 ports, if this controller has a limit of 1024 pixels per port, then port 1, no matter how it's split, can do 1024, port 2 1024, etc. Each remote has 4 physical ports and they're numbered 1 to 4, but those don't always follow a direct one-for-one correlation with the controller. When you connect a remote, the physical ports on the remote will correspond to the jack it's connected to, but not always a direct one-for-one correlation. So in this example, port 1 on the remote will be controller logical port 5. Port 2 on the remote will actually be controller port 6, and so on. When you add a remote and chain them together, they are still only connected to the jack on the controller labeled 5 through 8. So both remotes are actually connected to 4 logical ports, and that correspond to ports 5 through 8. And each of the 4 ports is now shared. Port 5 will be the first port on each remote and correspond to ports 5A and 5B. The second port on each remote will be port 6, and that corresponds to 6A and 6B and so on. This means you're controlling 8 physical ports, but splitting that data from the 4 logical ports of the controller. You only have the 4 ports. You see the numbers are 5 through 8. So think of smart remotes as form of a splitter. Depending on the controller and receivers that you have, you can put up to 6 smart remotes in a chain. That will give you 24 physical ports from the 4 actual controller ports. Just remember the receivers are like splitters, so you have to watch your pixel count per port. Controllers use differential data to go to the remote receivers. And this data can travel quite some distance. You can go up to 300 feet from the controller to the receiver, and that's pretty far. But just remember, at each receiver location, you're going to need the appropriate power supply. So here's a typical differential controller example. You've got the main box with the power and the receivers, and then you have the receiver box with 2 receivers. Here's a typical differential controller example. You've got the main box with the power supply, and then you have the receiver box with 2 receivers and connected to the pixels. And you can have, in this case, there's 2 receivers, so you could have 8 chains of pixels connected. Sometimes you'll have pixels close to your differential controller, and many times people will add a receiver or 2 in the same controller box with the controller. But things get a bit crowded doing it this way. So with that, you'd have the capability of doing something like this. You'd have the pixels connected to the receiver box and 4 chains, or in this case 8 chains. And in this case, there's 1 receiver, so you could have 8 chains of pixels connected directly to that main controller box. Now let's talk about hybrid controllers. Now, hybrid controllers are controllers that have local ports and receiver ports. And here's some examples. The F48 V4, it's a E131 DDP-based controller. It only has 4 local ports, so you're a little bit limited on that, but it is still technically a hybrid controller. Got the F16 V4, and this has 16 local ports and 2 receiver chains, and it's a E131 DDP-based controller. You get the Wally's WB16, it's an FPP-based controller, and it has 4 physical differential ports. You got the K8, which is FPP based and has 3 receiver ports. K16, 16 local ports and 4 differential ports. It's a FPP based. K32, 32 local ports and 4 differential ports, and it is FPP based as well. So here's a hybrid example. You could have as many pixels on the local ports as a controller can support. And then you have differential jacks to hook up to receiver boxes, and those receiver boxes can be up to 300 feet away. So you see it gives you quite a bit of versatility. So when figuring out your show design and layout, now let's go over design limitations. It's going to affect every show layout. There's too many variables to give you exact distances on any of these, and these are just based on reported averages. And what you come about could be more or less, even significantly so, depending on your setup. But some of the variables that we can't take into consideration is the controller, wire size, wire type, the pixels, the pixel type, the voltage. And all of those play a role in what your distance is going to be effectively in the different area. But based on real world practices, the average maximum distance for the controller to the first pixel is roughly no more than 30 to 50 feet. The distance between chained props or pixel to pixel is usually no more than 20 to 30 feet. And the distance for differential data is roughly around 300 feet. Now this one doesn't have a whole lot of variables in it, so that 300 feet is a pretty good figure. Another thing that you got to take into account is environmental limitations. For some reason, squirrels and rabbits love the taste of network cables. Don't know why, but they do. So there's some people that live in rural areas that have a problem with the squirrels and rabbits, so they try and reduce or even eliminate network cables. For some reason, they don't like the pixel cables as much, but the network cables, I guess it's like candy to them. So let me show you what I mean. So the distance from a port to the first pixel. So you got the controller going to your first prop, and that's going to be roughly no more than 30 to 50 feet. Pixel to pixel difference is the distance between props. And the more props that you have, that distance might get reduced, but like I said before, there's too many variables to give you an exact figure. This is just a ballpark figure. And the distance from a differential controller to the receiver. Now this one's a pretty good thing. It's right around 300 feet, and that shouldn't be a problem going that. There's not too many variables with that one. So here, let's put it all together. You've got a differential controller, a receiver, going over to the first prop, and then some props chained together. So the difference from the differential controller to the receiver is roughly no more than 30 feet. Then from the controller to the first pixel is no more than 30 to 50 feet. And then from prop to prop is no more than 20 to 30 feet. With these limitations in mind, now you can design your controller layout. So let's get to it. So here's a real world example. At this point, you might have already decided many factors, or you might be just at the initial stage. You might have already decided if you're going to use 5 or 12 volt. So if you're using 5 volt, you're going to have more of a need for power injection, so you need to take that into account. There's other videos on that subject, and that's going to make this video way too long if I get into that. You might already have your props built. For example, you might have your roofline already wired up, and if that's the case, pixels are directional. So if your roofline is going up this direction and then down, then your controller is going to have to connect to this end of the pixel chain. You can't just arbitrarily pick what side. Now in X-Lights you can design it however you want, but if it's already built, you're limited to that. You got to decide whether you want to do pixel packing or not and do power injection. You need to decide if you want your network cables or pixel cables to cross sidewalks, driveways, etc., because that could take a factor. you might have to run a lot longer pixel or data runs in order to not cross sidewalks or driveways. I like to not do it, especially network cables, because they have a tendency to get easily damaged. But it's all personal preference. 95% of our hobby is personal preference, not about the right way and wrong way. It's more about preference. So let's go over the process of designing our show for this layout using only one differential type controller. So you need to keep the design limitations in mind. And do you want to do your layout first or the controller design first? It's kind of like the chicken or egg. If you're just getting started, it's probably best to kind of do the layout somewhat and then do the controller and then adjust things to make it fit. But the bottom line is you could make it work no matter what you do. It might take a little more work, but no matter how you design it, you can make it work. So here's some design criteria in this that we're going to set as a basis for this presentation. So we've got the mini tree and stars is going to be 840 pixels. Each tree is 100 pixels with the star at 20 with 7 of them. And I'm going to put that on one port. So that's 840 pixels total. So that means I'm going to have to do power injection. The mega tree is 2400 pixels and I want to use 8 ports of 300 pixels per port. And if you're using 5 volts, you might have to do power injection. I'm going to run the star by itself on one port. And the reason for that is because I've already got the chain 4 strands of pixels going up and down for 300 pixels. If I were to chain that star at the end of the last string, I'm probably going to need power injection anyway, so that's an additional wire. So I just wired it with one port, and I might decide to go with a more dense star later down the road, and it just makes it easier for expansion. Now the candy canes. I've got 4 candy canes in each chain. I want to connect them all together on one port. Each candy cane is 99 pixels, so that'll be 396 pixels per port, and I'll need to have power injection. The singing trees was 246 pixels per tree, and each one I want to put on a separate port. If you're going with 5 volt, you're probably going to have to do some sort of power injection or power balancing. The matrix is 4,320 pixels. I want to do 8 ports of 540 pixels per port, so obviously I'm going to have to do power injection. So, since differential data can go 300 feet, you're pretty much free to put the controller in any location, in the yard, the garage, whatever. For this example, we're going to put it in the garage so that we don't have to build an enclosure and that it's easy to get access to the network that's inside. But this isn't the only place, and it can be done just about anywhere. I like to start with the section that's going to require the most number of ports. So we're going to start with the yard. So the mega tree is taking 2400, like I said, 2400 pixels. We're going to use 8 ports and the star 1 port. So we're already using 9 ports, so we need 3 receivers. In this case, a differential controller might not be the best option. It might get a little bit crowded, but that's totally personal preference. What's crowded to me might not be crowded to you. Some people would put the main controller in the same enclosure, and like I said, that's preference. So these receivers, we're going to connect up the leaping arches, the mini trees, 840 pixels, the presents. Now at this point, we've used all 12 ports that the 3 receivers provide. So we have an option that we could add more receivers to the box or add another receiver box. In this case, my preference is going to add another receiver box, and we'll get rid of the other wiring so that it makes it a little bit cleaner. And from this receiver, we're going to wire the snowman, we're going to wire the candy canes. Remember, that's 396 pixels. Then we're going to go the window snowflake to the roof, and that's 255 pixels. So if you're using 5 volts, you might need power injection. Now I could try and add the door and snowflake combination to this port, and that's 183 pixels, but that would make it 438 pixels on the port, and I'd need power injection. Like I said, I like to limit my power injection as much as possible, so we're going to put it on the fourth port. So we've used all the ports on this receiver. So let's move on to the singing trees, since it's simple. And as you see, we're not running cables across the sidewalk because that doorway we naturally made a cross over it, but it went overhead through the pixels. So let's do the singing trees. So the singing trees is fairly simple. We've got the receiver and one port per tree. That takes care of that receiver. So now let's go on to the left side of the house. The matrix is 4,320 pixels, designed for 8 ports. So it's going to take the 8 ports on both receivers. And I'm not going to throw all the cables on there. So now for the rest of the house. We need to add another receiver because we're full. And that one receiver, you're going to do one port go to the roof line and snowflakes. The other port's going to do the garages. Then we're going to do the candy canes. And the candy canes are going to need some sort of power injection. Now, we do have an extra port, so if we wanted to split this roof line, we could and reduce the potential of having power injection. So now that we have everything designed, now we need to run the cables for the controller to each of the receivers, and it'll look something like this. And with this design, you see that we don't have any areas that should violate our design limitations, like I mentioned. But there are several ways this could have been built, but this is just an example. And don't forget that you'll have to have some way to connect your controller to your network. So the pros with this configuration, with the differential, is you can get many ports. Like I said, you got the K128 that gives you 128 logical ports, and that correlates to multiply that times 6, a lot. And you can go long distances. So if you have a wide spread out display, that works good. You get a lot more flexibility of different voltages because essentially for every 4 ports, you could have a different voltage. The cons is there's a lot of data cables. Also, you're limited with the number of ports in one area without taking up a lot of space. And it's potentially quite a bit more expensive doing it this way, but that will vary on your show layout. It might be less expensive, but that's just something that you need to look at. So we're going to use the same design criteria as a previous example, and we're going to create our layout using only local port type controllers. Typically, when using a local port controller, you want it centrally located to minimize the length of your pixel cables because that distance is somewhat limited. But since the majority of the props are in the yard, and especially like the number of ports for the mega tree and star, we're going to put it over by the tree because that would be a lot of cables running from the main part, and I don't think we'd get any advantage with moving that centrally located, as you'll see in a minute. So we're going to do essentially the same thing as we did on the other controller. We're going to do the arches, then the mini trees and stars, then the windows, snowflake, and then roof line, then the candy canes, then the snowman, then the presents, and then the door, snowflake, and the entry roof. And that takes up all 16 ports. Now we could have used another controller like the K32 for the rest of the pixel runs, but I have a feeling that even with F-amps and power injection, it still might not run properly. And from a design perspective, we don't want to assume and then build it that way and find out that it doesn't work, because then we might be finding ourselves trying to find a controller last minute or whatever. But then again, it's preference. 95% of this whole hobby is preference, and my preference would be to use another controller. So we're going to add another controller over to the left side of the house. Like I mentioned, the matrix is going to use 8 ports. Then we're going to do the candy canes, then the garage doors, then the roof line and snowflakes, and then the singing trees. But due to this distance, even adding F-amps and power injection, that distance might be a little bit too far based on our controller and our wires and all of that. So it might be better just to add another controller. And we could do something small, like a K4 or K8 in this. And again, we're going to use one port per tree. So with this design, we don't have any areas that should violate the design limitations I mentioned. And then the networking part of this is fairly straightforward. You'll need a switch, or if you have enough ports on your router, and then the 3 cables just go into each controller. But this is just one way. Like I've mentioned, in this hobby, there's hundreds of ways to do everything. And the right way is the one that works for you. So the pros with this configuration with the local port. You can get many ports in a local area. You got smaller controller space requirements. You got fewer overall components and fewer data cables. Cons are, you're limited in the distance that you can transmit pixel data. You're potentially going to need more controllers, and you've got limited voltage differences because most of the controllers you can only split the controller in half and control half with one voltage, half on the other. Some you don't have that limitation, but that's going to be controller dependent. But that is only based on this design. Okay, we're going to use the same design criteria as the previous example and create our layout using only one of the hybrid type controllers. So if you remember, we're going to have a mega tree that's going to use 8 ports and the star 1 port, so 9 ports are being used. And we're going to do essentially the same thing. Going to wire the arches, the mini trees and stars, the window, snowflake, and roof line, the candy canes, the snowman, the presents, and the door, snowflake, and entry roof. We've used all 16 ports of the controller, and due to the difference, we're going to run a differential receiver to the singing trees. And just like before, we're going to do 1 port per tree. Then we're going to run a differential receiver to the left side of the house. And if you remember, you can go 300 feet, so to avoid crossing the sidewalks and driveways, you can just run the cable up over the top of the roof. And this receiver, we're going to do the left roof line and snowflakes, the garage doors, and the candy canes. Now you've only used 3 ports, so you have 1 port left. So if you want to split these 2 roof lines on separate ports, you could, and that would reduce or even eliminate power injection if you need it. So let's go to the matrix. The matrix needs 8 ports, so you're going to need 2 receivers. But let's pause at this point. You have to be aware of how many differential outputs your controller has. Some hybrid controllers only have 2 outputs and others have up to 4. If your controller has 4, then this is no problem. Just connect each receiver to its own differential output. But in this case, if your controller only had 2 differential outputs, you probably wouldn't be able to wire it this way and have to add another controller. If it had 3, then you'd be creative and make it work. You could probably use a couple of the receivers in smart mode. A simpler method would be to use the receivers for the matrix and configure them in smart mode. But depending on your controller, you still might not be able to do that. If you remember, when using remotes in smart mode, they're sharing the logical controller port capacity. In this case, our matrix is using 540 pixels per receiver port. So using the receivers in smart mode, you'd be combining those on 2, so you'd be doing 1080 pixels on the controller's actual logical port. So this could be a problem if your controller doesn't support enough pixels per port. There's a lot of controllers that only support 1024 pixels per controller port, and some even less. The Culps and other BeagleBone-based controllers can support about 1600 pixels per port at 20 frames per second. So you think that we're stuck, but you got to take and kind of look at the overall picture. Sometimes the easiest isn't always the best. Wiring those two controllers together at Smart is easier, but it might not work. But you could daisy chain the receiver for the singing trees to the receiver for the left side of the house and make it work. So the trees are 246 pixels per port. And if you look at the receiver on the left side, it's controlling 304 pixels for the roof lines. So that would put the total pixels per the controller's physical port at 550, which is way under the amount typically. Port 2 of the left side receiver is controlling 206. If you combine it with the tree ports, that's going to put the controller physical port or controller logical port at 452 pixels. And port 3 of the left receiver is controlling 396 pixels for the candy canes. And if you combine that with the controller for the trees, that puts that controller logical port at 642, which is still way under the limitations. So sometimes you got to kind of think outside the box and make it work. So the controller cabling, if we're going to use a 4-output controller, it's going to look something like this. I'm going to go from the controller to the left roof receiver, a controller to each matrix, and the controller to the singing tree. For a 3-output controller with the ability to chain the matrix controllers, it's going to look something like this. Controller to the left roof receiver, controller to the first matrix receiver, from the first matrix receiver to the second matrix receiver, and then the controller to the singing trees. Now for a 3-output controller, where you don't have the ability to chain the matrix controllers, you're going to have the controller to the singing trees to the left roof receiver, controller to the first matrix receiver, then the controller to the second matrix receiver. And as far as the network cabling, you just need a single network cable going over to it. So with this design, we don't have any areas that should violate the design limitations I mentioned as far as distances from pixels and controllers. Now you could use something like the K32 that has 32 ports, but like I mentioned before, even if it was centrally located, I'm not sure if you'd be able to make it work even with power injection and FMs. That, like I said, that's only something that you could do by testing in your environment. Someone else's environment could be totally different than yours. It might work for them and not for you, or vice versa. Doesn't mean you can't do it that way, but it's just something to consider. So the pros of this method. Pros are you get many local ports, and you get the ability to do long distance port, gives you a lot more flexibility, and you run fewer data cables. The cons is that sometimes you're limited on your long distance ports, and you could run it across potentially your port limits when you're daisy chaining the smart receivers and stuff. But you don't, every design layout is going to be different. Okay, so now we're going to use the exact same design criteria as the previous example and have our layout using a combination of controller types. We're going to use one local port controller and one hybrid controller and make it just a little bit easier. So same criteria. We've got the mega tree with 8 ports and star 1 port, so 9 ports is accounted for, and the rest of it's going to be the same. So we're going to have the arches and the mini trees, the window snowflake roof line, candy canes, snowman presents, and the door entry. So we've used the ports. Then we're going to add another controller to the left side of the house. The first 8 ports are going to be for the matrix. Then we're going to use one port for the left roof line and snowflakes, another port for the garage doors, and the last port for the candy canes. And that leaves you 5 ports. So you could split the roof line and even have room for some more expansion. Then, because it's a hybrid, we're going to run a differential receiver for the singing trees, and then run 1 port per tree. And the networking for this would be, you might have to add a switch if your router doesn't have enough ports, and then just the cables. So it's not very complicated. So the pros with this: you can run many local ports, and you can go long distances. You got the flexibility of different voltages, fewer data cables. You have potentially fewer you have potentially fewer controllers if you were going with a local port only design. But if you're using another design, it goes into the con where you're going to use potentially more controllers than, say, for example, the differential controller. But each method is going to depend on the actual design that you're using. So let's talk about the multi-sync method. This isn't really a controller type design since it uses any or all of the previous controller types. It's more of a communication method for your controllers. It does require a decent Wi-Fi signal to all of your devices, but the network traffic is next to nothing. So the impact on your network traffic isn't going to be affected by this, because it sends out very small packets. So we're going to use the exact same design criteria as previously. So you got the mega tree with 8 ports and the star with 1. And then we're going to do the arches and the mini trees and the windows, snowflake, roofline, and candy canes, the snowman, the presents, and the door entry roofline. So all 16 ports have been used. So we're going to add another controller to the left side. Going to have 8 ports for the matrix, the left roof line, garage doors, candy canes, and we're going to have 5 ports left so we could split the roof line if we wanted to, and we have room for expansion. Then we're going to add another controller for the singing trees, and that could be a relatively small controller like a K4 or K8, and again 1 port per tree. Now here's the nice part about multi-sync over Wi-Fi. Your Wi-Fi router will send very small sync packets to all of your controllers, and this is what your data cables look like. You have none. It's all handled wirelessly, so it really cleans up the layout a lot. So the pros and cons of a multi-sync. The pros are you got many local ports. You can go long distances. There's people that have done entire streets using a Wi-Fi multi-sync. There's a guy that last year had a huge park and he had 73 controllers all connected through multi-sync Wi-Fi, all in sync. You got the flexibility of different voltages and you have way fewer data cables. All of the methods have the same pixel cables. So let me show you the differences in the data cables needed for each one. Here is the multi-sync, and as you see, there's no data cables. If you went with the local port type controller, you have a few more data cables. If you went with a hybrid, then a few more. And then if you went with the differential, quite a bit more. Now I'm not saying that any method is better than the other, just demonstrating the differences. Some people might have an aversion for data cables, and if that's the case, this method might not be for them. But that's preference and for you to decide. The cons with this method is it's going to take more controllers and they need to be FPP based, but you can get around that by just adding an FPP device to the controller like a Raspberry Pi. And it won't work for everyone because if you don't have a decent Wi-Fi signal out in the yard where the controllers are, then it won't work. There are people that have run across that and they'll add an access point that's out in the yard to make it work. So any of these methods you can make work. It just depends on how much work you want to do to make it work and what you want to go through. So let's go over a recap. So what's the right way? The right way is that works for you and that you want to do. Any of these ways I mentioned is going to make your lights blink and flash in sync with the music. Not a problem. It's about your choice and how you want to make it work. Mix and match. You can combine any of these methods together. You can have part of the show be multi-sync, part of it be differential, and part of it local ports. That's totally up to you. They all work and they work together. So there's a common saying out there, penny wise and pound foolish. I've helped a lot of people who've purchased a differential controller and were struggling with the configuration, especially with the F48 V3 type controller because of the bank limitations it has. But I noticed their layout had a whole bunch of local ports and their controller box was jam-packed with these receivers. So out of curiosity, I asked them why they went with the F48 or really any of the differential type controllers. And almost all of them said that they bought it because it had more ports, so it had to be better. And since they only had to buy one controller, it was going to be cheaper. But like I said many times, the best way is the way that works for you. And because they chose that way, it must have been the best way for them. But if you look at the cost of just the major differences in the components needed for the design that we have here, you see what it is. But each design method might have a different opinion on what's best for you. Your layout might make it to where it works out differently, but this is just based on this design and the current costs that we have now. So for this example, I'm using Culp controllers for a couple reasons. The primary reason is the K16 has 4 differential jacks, where the F16 V4 only has 2. And as you saw for this layout, if I used the F16 V4, I would have had to buy an additional controller, enclosure, and power supply. I'm not saying the Culp controllers are better. They just might be better in this situation. So the differential and hybrid type controllers, they're going to only have one spare port. The local port and multi-sync method, they have 5 spare ports. So if you want to put the differential and hybrid basically on the same playing field, you'd have to add 2 more receivers for $60 more. But I'm not going to take that into account because just to put it on the same level field, if you're not using it, it really doesn't matter. So the hybrid method is $202 less expensive than the differential method. That's quite a savings. The local port is $15 less than the differential, but it's $187 more than the hybrid. The multi-sync method is $52 less than the differential method, still less, but it's $150 more than the hybrid, but $37 less than the local port. But money shouldn't be the only deciding factor. Maybe messing with network cables year after year and possibly replacing the damaged cables isn't worth the $150 that you would save. Maybe you're in a rural area that cables keep getting chewed by animals and cables aren't even an option. So what's the best method? It's the one that works for you. They're all going to work. They're all going to give you a great show. A different layout or design might give you entirely different results than we have here. I just picked one design to give an example, and it's not meaning that this is the only way. I'm just showing things that aren't always the way they seem without looking at all the details. So, in doing it, be aware of your controller specs. Make sure you have enough ports. Make sure if you're doing a hybrid that you have enough receiver ports, and the ports per, or the pixels per port limitations. If you're using one of the Falcon V3 controllers, you have the bank limitations, and that's bit people a few times. So that's one thing that you need to be aware of. But when you're doing your research, be careful of doing Google searches. Google's a great tool, but there is a vendor out there that has bought Google Ads, and when you search for certain controllers, his website will come up top on the list. It'll look like it's the vendor for that controller, and then he has a video that goes through and explains how terribly designed this other controller is compared to his, but the design flaws that he points out in the video, he doesn't go on and explain that those exact same flaws exist in his controller, but even to a greater degree. His video has some misinformation and some downright lies. So you can't believe a video 100% that's produced by the vendor. So just be careful. Okay, I hope this video gave you some good information and helped you on your journey to having a successful show. I've got links down below for some good references and other sections that will help you out. If you have any questions or anything, just drop me a note. And good luck with your show and have a great day.